I'm going to go over some problems for the exam one review. Um, I'm not going to work every problem. I'm going to try to hit the high points, but notice at the beginning you have your resources. You've got the calculator link. You probably won't need that very much because if you need a calculator, there's an embedded calculator in each question. But you also have the StatCrunch link where if you click on that, it will open up the tab to log into StatCrunch. You can use that during your exam. And then you also have the exam one handout link that you can open during the exam. You can also print this if you want to and make some notes on it or highlight anything that you feel is important. So that is all available to you now and while you take the test. The first part of this review will be similar to the first part of the test where you have some vocabulary. Make sure you know the difference between sample and population. The first couple problems are asking about that. Remember, number 4 is asking if this is a statistic or a parameter. Remember, statistic is a data value that describes a sample. Parameter is a data value that describes a population. So if I have 20% of vehicles sold are compact cars, that's going to be talking about 20% of all vehicles sold. So this would be a parameter. Here I've got, as of January 2007, 44% of the governors of the 50 states in the U.S. are Republicans. Again, that's talking about all the governors in the 50 states, so that's also a parameter. Now you might want to go through here when you're practicing and do similar questions because it's going to generate different examples. So like I got both parameters here. If you do a similar question, you're going to get different options. Some of them will be statistic and some of them will be parameter. On number 6, it's asking if the data is discrete or continuous. Remember, discrete is if you can count it in whole numbers and not parts, like fractions or decimals, it's discrete. If it is not just whole numbers, it's continuous data. So anything that's like a measurement or volume or liquid would be continuous because you don't just have whole number parts, you have pieces of it or fractions of it. So the volume of a sphere is going to be continuous because it's not going to be exactly like 2 or 3 or 4 whatever cubic centimeters or whatever you're measuring in. Molecules of water, you can only have whole molecules, so that's going to be discrete. If you can count it with your fingers, it's going to be discrete. Acceleration of a car from 0 to 60, you don't just jump from 0 to 60, it goes all those miles per hour between, so that's going to be continuous. And then height is also going to be continuous because you're not just 5 feet or 6 feet, you're 5'4" or 5'8" or 5'7", so it's continuous. You have all those parts between. That's more continuous, discrete. Number 8 is talking about quantitative or qualitative. Quantitative is measurements, usually numbers. Qualitative is like labels or categories. You do need to be careful because there's a couple instances where numbers can be qualitative. For instance, like talking about jersey numbers or social security numbers or ID numbers, that would be qualitative because those are labels for certain things. So here, the data you collect is age in years. That is going to be quantitative. The data you collect is habits, as in always, sometimes, never. Those are labels, so that would be qualitative. So just go through these, practice. If you are getting them wrong, do the similar question. It will generate different examples until you get good at practicing them. I'm going to skip down here. Those are all covering qualitative and quantitative, whether it's continuous or discrete. Number 15, you're labeling what type of sample it is. So make sure you know the difference between convenient, stratified, systematic, simple random, and cluster. So a survey, the first 100 students that arrive on campus, that's going to be just a convenient sample because it's just the easiest one to do. Survey everyone whose first class is in building 2 or 7. That is going to be your cluster because you've broken it up into groups, which are your buildings, and then you've gone and surveyed everyone in select groups of buildings. So that will be your cluster. Randomly choose 100 students by having a computer choose them from their vids. That is going to be your simple random sample. Survey 25 nurse majors, 30 engineering majors, and 10 English majors. That will be stratified. That's where you break them up in groups and then survey some from each group. So we've got some of the nurses, some of the engineers, and some of the English majors. So that's your stratified. And then survey every 10th student as they arrive on campus. That's going to be your systematic. Like there's some system every so often, every 25th, every 10th, and so on. So make sure you know your different sampling methods. And again, this is a good one to do the similar question on because it'll generate you different examples. The next thing you're going to be asked about is your levels of measurement. Remember, nominal is just like names and labels. Ordinal means I can put the data in order, but I can't subtract it. Interval means I can put it in order, I can subtract it, but it doesn't have a zero starting point. And then ratio is I can do everything. I can put it in order, I can subtract it, and it has a zero starting place. And again, these are good ones to do similar questions on. So on this one, it says the number of hours a student studied in 1 week. I can put that in order. I can subtract. I can say, oh, this student studied more than the other student by subtracting their hours, and they start at 0. You're not going to have a negative amount of study hours, so that makes that ratio. On this one, letter grades, A, B, C, D, F, I can put them in order from worst to greatest, but I can't meaningfully subtract them. So that would be ordinal, where I can put it in order but can't subtract. Gender is going to be nominal. They're just labels. I can't subtract male from female, so that's not going to give you any meaningful way to subtract anything. So again, practice these, do similar questions. That gets us to number 21, where we've got a frequency distribution. And remember, this is the seconds you wait when you call a cell phone service company. So 9 people have to wait 60 to 119 seconds. 28 people have to wait from 120 to 179. So this is how many people waited this long. So when it says how many individuals are included in the summary, you're going to add up all the frequencies to get the total in your survey. So just use your calculator, add those up, you would get 60. And then it asks, is it possible to identify the exact values of all of the original wait times? Well, this would be no, because it's giving me a range of wait times, not exactly what they are. I know there's 9 between 60 and 119, but I don't know exactly what those 9 wait times are. So this is giving us an estimate, but not the exact wait times. Number 22, we've got another frequency distribution. This one is dealing with the length of fish. And it wants to know what the lower class boundary for the first class is. Well, here, let me turn this over here. If I want the lower class boundary, that is going to be the end. These are all the low sides. A boundary, think of a boundary as a fence or something that surrounds it. So the class boundary is going to be what's between the end of one class and the beginning of the next. So the class boundary between the first and second class would be 144.5. You can just take the average of 144 and 145. The class boundary between our second and third class would be 149.5. So what's dividing the end of the previous class from the next? So if I want the lower class boundary for the first class, this one's a little tricky. That's going to be your very first class boundary. So working backwards, right before 140 would be 139.5. So that would be the lower class boundary for the first class. If I wanted the lower class boundary for the second class, that would be 144.5. So just be aware, make sure you're not included in any of the class ranges. You're what's separating one from the next. If it helps, you can list your classes out like this. And ask yourself what comes between each one. And then even though we don't have something to compare this to, you can kind of find the pattern. So if this was my 144.5 and this was my 149.5, we know that right before 140 would be 139.5. So that's another way to go approach that problem if you're asked for the very first class boundary.